Yeah, and during class I didn't want to go into this. I mean, for this one problem, remember there was like a vector given by the coordinates 3 and then 1, 2, 3, 4. So be vector like that to find like vectors which are unit vectors, right, and which have an angle of 60 degrees. And of course 60 plus 60 is 120. You know, the angle to the y-axis less than 45 degrees. So it's I mean it's pretty clear it would be vectors something like this from the picture. Okay, so if I'm not doing it in an elementary way, there's like a very conceptual way to do that, and I thought I'd just talk about it. If you know something about polar coordinates, you might actually figure it out by yourself. The point is, if you have given a point in, let's say, x comma y, then this, you know, you if you look at rotating that that vector, right? I mean, by an angle, there's a very conceptual way of doing that, which is multiplying a 2 by 2 rotation matrix with a vector. And if you forget how that goes, another way to memorize it is to think about points in the plane as complex numbers, having a real part and an imaginary part. And multiplication by e to the I alpha is in fact rotation by the angle alpha, where now alpha is actually a directed angle. Engineers got to know that anyway. So this is cosine alpha plus I sine alpha. And if I multiply that by some x plus iy, and I know how to multiply complex numbers, right? You get cosine alpha x minus sine alpha y, and you get plus I times sine alpha x plus cosine alpha y. And the best way to kind of like to see this calculation is really by making it real and writing the vector in the form xy and having a cosine alpha here, having a minus sine alpha here, having a sine alpha here, and a cosine alpha there. So this is a rotation by alpha. And the way if you compare what I have up there, if you compare that with you would take cosine alpha x minus sine alpha y, and for the first component, and sine alpha x plus cosine alpha y for the second one. So in our case, this is easy, and you know, and unit vectors get rotated in unit vectors. So you have this vector, and then you have cosine of 60 degrees, that is 1/2, minus sine of 60 degrees is this. Here you get square root of 3 over 2, and here you get 1/2. And now you just kind of like have to multiply that out. So this is like 3 over 10, like 1/2 times 3 over 5, minus 4 times square root of 3 over 10. Second one is 3 times square root of 3 over 10 plus 4 over 10. Of course, a much nicer way to write it is 1 over 10 times 3 minus 4 times square root of 3. And here you get 4 plus 3 times square root of 3. So here you have like a slightly, you see this here, this solution corresponds to this vector here, right? Because this is my plus 60 degrees rotation. And you have like a slightly negative number, you have a positive number. If you calculate that, that completely perfectly fits the picture. And correspondingly, you know, so the other solution is given by having like a rotation by minus 60 degrees away from that unit vector. And so all what happens is that the minus sign flips because of the cosine and sine. And so 3 over 5 4 over 5 equals, and that will be 3 over 10 plus 4 times square root of 3 over 10. So that's a relatively large positive x component, and then here you're gonna get minus 3 times square root of 3 over 10 plus 4 over 10. That's a very small y component, okay, negative. Okay, so this is 1 over 10 times 3 plus 4 times square root of 3, and 4 minus 3 times square root of 3. So this is supplementary. I don't really expect that you know how to do that. I thought if somebody might be interested in how you get the solution easily, that would be a way to do that.